So in this video, we're going to use the quadratic formula to solve these equations. These examples are actually all the same examples we did for completing the square. And I wanted to show you that the quadratic formula is a little bit nicer than completing the square in terms of steps. So I'm just going to identify A, B, and C really quick in this equation. So A is 2, B is 20, and C is 48. And you're going to want to get your calculator ready because you're going to work through the quadratic formula with me. Now, the best way to memorize something is to write it down every time you use it. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you want to have this formula memorized, write it down every time you use it in the homework, and you'll have it memorized for the exam. Trust me, it'll be very embarrassing if you don't have this formula memorized for the exam. So make sure you just rewrite it every time. That little step will help you remember it very easily for the exam. Okay, so let's go ahead and plug in our A, our B, and our C into this formula. So B is 20, so this is going to become negative 20 plus or minus the square root of, this will be 20 squared minus 4 times 2 times 48 all over 2 times 2. Okay, so what I'm going to do is I'm going to simplify what's in under the square root. And I'm going to actually put it in all at once. So 20 squared minus 4 times 2 times 48 is, 48 is going to come out to 16. I didn't need this giant square root there. A little square root will do. All over 4. Well, that's nice. 16 actually evaluates nicely. The square root of 16 is 4. And now I have two possibilities. I have the possibility where x equals negative 20 plus 4 over 4 and negative 20 minus 4 over 4. So negative 20 plus 4 is going to be negative 16 over 4 is negative 4. And down here, negative 20 minus 4 is negative 24 over 4 is negative 6. So there's our answers, negative 6 and negative 4. That's what x equals. All right, let's try it again. This time, A is 1, B is negative 3, and C is negative 2. So let's plug that into our quadratic formula, which I'm going to take a moment and rewrite so that hopefully you do that as well and memorize it. Okay, so in this case, now because B is a negative 3 and we're plugging it into negative B, it's actually becoming positive 3. So the double negative becomes positive 3 plus or minus the square root, negative 3 squared minus 4 times 1 times negative 2 all over 2 times 1. All right, so we're going to figure out what's under the radical then. So negative 3 squared is positive 9. That's going to be 8, so that's going to come out to 17 over 2. And actually, that doesn't simplify at all. 17 can't be reduced. We can't even factor anything out of the radical. That's the answer. So you may need to list it as two separate answers, but I'm okay with it being listed as one fraction with the plus or minus. That's perfectly acceptable answer. Or if you want, you could break up the 2. So it's 3 halves plus or minus the square root of 17 over 2. That's another way you could write the answer. All right, let's try it again. So this time it's not equal to 0, and I need to make it equal to 0. So I'm going to minus the 2x and the 7 from both sides. I don't really have space for that, so I'm just going to write 3x squared minus 2x minus 7 equal to 0, and there we go. So A is 3, B is negative 2, C is negative 7. I'll write my quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a. All right. So now we'll go ahead and plug in negative b, so because it's a negative 2. So, negative b, but b is negative 2 is going to become a positive 2. I said that very funny. Plus or minus the square root of, okay, so b squared is negative 2 squared minus 4 times 3 times negative 7. All right. So all over 2 times 3. Okay, let's go ahead and figure out what we have here. So this is going to come out to 2 plus or minus the square root of 88 is what I'm getting. And over 6. So I'm figuring out 4 times 3, which is 12, times negative 7 is positive 84 because of the two negatives. And then that negative 2 will square to be positive 4. Those two will add up to 88. Okay, but 88 actually can be reduced. So I could factor out a perfect square. And here, I'll just do this on the side, thinking of 88. 88 is 4 times 22. And 22, by the way, is 2 and 11, which neither of those are perfect squares. But 4 is a perfect square. So I'm going to rewrite, or I'm going to think of 88 as the square root of 4 times 22. And then the square root of 4 is 2. And then the square root of 22 is just going to stay under the radical. So 22 is going to stay under the radical. 4 is going to come out as 2. All right, so let me rewrite this. I have 2 plus or minus 2 radical 22 all over 6. So this actually can simplify because 6 reduces with both of these numbers here. I can reduce all of those numbers by 2. So that's going to be, 1, a 1, and a 3 if I'm dividing all of them by 2. So my final answer then, we'll just write it below since I don't have enough space. 1 plus or minus the square root of 22 over 3. I don't have to put the 1 in the front. It's okay if you do, but I don't need to. Okay, let's try another one. So this is in the right form. I don't have to move anything around. Let me go ahead and rewrite the formula. And we'll just plug it in. And I hope you're seeing that really it's just a matter of simplifying the square root. That's kind of like the big important part here. I'm trying not to mess up your signs and simplifying the square root here, actually. That's going to bother me. It looks very messy. There we go. And that's a squared. And that's a C. Very sloppy. Oh, well, here we go. X equals. So again, it's a negative 4 that we're plugging into negative b. So that's going to become positive 4 plus or minus the square root of negative 4 squared minus 4 times 2 times 21 all over 2 times 2. All right, so let's figure this out. So that's going to be 16 minus 168. So that's actually going to come out to a negative 152. All right, we saw, over 4. We saw negatives under the square root before. That means we need to pull out an I. So I already know that I have an imaginary number I out in front, okay? Now I do need to see if I can simplify 152. So let's go ahead and divide out and see. So it looks like 4 times 38 works, and 38 happens to be 2 times 19. So that doesn't really help me. So this is what we're going to simplify it to. And so it's going to become 2 square root 38. But then there is an I as well. So it's going to be 2I square root 38 all over 4. Okay, now I do see I can do some simplifying. Oops. Yeah, there we go. I can simplify all of these, but With imaginary numbers, we're actually going to do a step a little bit different. So they like to put imaginary numbers into a very specific form. They like to put it into here. I'm trying to get rid of all of the highlighters there. Okay. They like to put it into the form a plus bi. So the a term being the real number part, the b being the I number part. I mean, the imaginary part is what they call that. So we're going to break this fraction up. So I'm going to break this fraction up as to 4 over 4 plus or minus 2i square root 38 over 4. Okay, and now I am going to simplify this. So 4 over 4 is just a 1, but 2 over 4, that actually reduces to 1/2. So I have a 1i over 2. That's a perfectly acceptable answer for me. But they might want it again, they like that form a plus bi, so they often like to put the I at the back. So they will write it as square root 38 over 2 and then I at the very end, so that we're seeing that a is 1 and b is the square root of 38 over 2. That's kind of how the form that they like to do those imaginary numbers in.